Hello, ladies and gentlemen, and we are looking at 3.4, determining the equation of a line. Now remember, you need to have finished 3.1, 3.2, and 3.3 before this. Hopefully that's done. If not, then stop the video now and go back to yesterday's post. So 3.4. The equation of a line can be determined from a graph by finding its slope. So we find its slope first, and then we identify the y-intercept. And remember, we're taking this from a graph. So they're going to give us a picture, and we have to come up with the equation of the line from the picture. The equation of a line can be determined if you know one point on the line and the slope. So this is a different situation. If I know one point on the line and the slope, I can also come up with the equation of a line. So I can do it if I know the slope and the y-intercept, which is a specific point. I can figure out the equation if I know a point, any point, and the slope. And finally, if the slopes and the coordinate of one point are known, the y-intercept can easily be found by patterning or substitution. And we're going to show you how to do that later today. So right up here, I'm telling you, if I give you a picture, a graph of a line, and if you can figure out the slope and at least one point, we can determine the equation of the line. That's what I'm trying to tell you here. Okay, so determine the equation of a line from the graph. Example 1. We have to express the equation of the line in y equals mx plus b form. There are different forms of a line. This is one form, and it's called the slope y-intercept form. It's the one that we use most, especially in grade 9. So this is the slope y-intercept form. And it's called that because you can easily see the slope value, which is m, which is rise over run, and we can easily see the y-intercept, which is b. Which means it crosses the y-axis at 0, b, because we had a big discussion about that if we're going to be a y-intercept, if we're going to be crossing the y-axis, it's going to be at the point x equals 0. Okay, so here is the question. I'm giving you this line, I'm giving you these scales, and I want to know the equation of that line. Well, step 1, let's calculate its slope. You can calculate the slope of the line between any 2 points. And remember, slope is equal to rise over run. So if I start at this point, and if I go to this point, I can easily work out my rise and my run. Now I do my run first. It's 1, 2, 3, 4. That is my scale. So the units going across are 4 units. That is my run. Remember, run is horizontal. If I'm running away from a bear, I want to run horizontally as fast as I can. This is your rise, going up. I think rise makes sense. A rise is going up a ladder or going up in an elevator. It's how you go vertically. And so our rise seems to be 1 unit here, noticing my scale, and I'm going from 2 to 3. So that means that my slope is, using rise over run, 1 over 4. Now, I don't have to find the slope any other way. That's a perfectly fine way of finding the slope. And notice it makes a 90-degree angle. The first thing I want to talk about is the fact that we could have used different points. Let's say I wanted to use this point and that point. So let's say I came like this. That is most certainly a different triangle. But if we look at it, I'm going to go 1, 2, 3, 4, 5, 6, 7. Does it go far enough? 1, 2, 3, 4, 5, 6, 7. Okay, let's not do that. It's not lined up perfectly. I should have 8 along here. And what's happened is I've put this line in and it hasn't matched up perfectly. So let's pretend that this is 8. It's not, but let's pretend. And this would be 2. And what that would give us is a rise over run of 2 over 8, which we can reduce down to 1 over 4. Now again, I'm lying. This isn't 8 units. I've goofed up. But if it was drawn properly, that would be 8. Yes?
If the actual rise and run was 2 over 8, would you have to reduce?
Yes. Reducing is something that you have to do. And the way to know that, or how to reduce, is you know that that's going to be 2 times 1 over 2 times 4. So you've got a multiple of 2 in the top, you've got a multiple of 2 in the bottom. They reduce down to 1 over 4. So yeah, we always put it in lowest terms.
And
yep.
if it's the number isn't even,
Mm-hmm.
say it's 5 or 9.
Yep.
How would you get the whole number? Would you do the big number?
You wouldn't. You'd leave it alone. You always leave it as an improper fraction. So what you're asking me is, if you have 5 over 9, we would leave that alone. And if you had 9 over 5, we would leave that alone.
Okay.
You wouldn't change this one to a mixed fraction. You would not change that to 1 4/5, because that's really hard to deal with in terms of rise over run. This is rise, this is run. Okay? Now, the one other thing that, if you look back in some of the, well, we'll get to that in a minute. Determine the y-intercept. Well, if we look at this graph, we can find the y-intercept just by looking at it. It's right here. It's where it crosses the y-axis. It crosses the y-axis at 0, 2, which means the y-intercept is 2. So we know the slope, we know the y-intercept, so using y equals mx plus b, we get y equals 1 over 4x plus 2. And the other way that this could be written, just so that you know, is it could be written as x over 4 plus 2. So it could be written as 1 over 4x or x over 4. And the reason for that is 1 over 4x is the same as 1 over 4 times x over 1. Top times top, bottom times bottom, x over 4. And that's why that can be written like that. You don't have to, and in fact I would argue that 1 over 4 is a better way to write this at the moment. But you are going to see it in this form different times. I'm going to pause the video there and I'll be right back.